There is one thing we do every single night. We go to bed and we enter an unconscious world whether we like it or not. Let me ask one question to everyone here. There is no judgment, so feel free to raise your hand if you ever procrastinated to go to bed. I can see quite a lot of people raising their hands, but hopefully after this talk, we can all appreciate our sleep because during sleep, your brain is doing something very special for your memory. Hi, my name is Jisoo Choi, and I recently graduated my PhD degree in neuroscience at McGill. Our team has been wondered how sleep contributes to memory. And in mammals, the sleep is not homogeneous state, but it has two distinct sleep stages. So one stage is called rapid eye movement sleep, known as REM sleep, and another stage is called slow wave sleep or non-REM sleep. And our team is particularly interested in this REM sleep because during the REM sleep, your brain activity is very similar to awake state, and it is the time when you are vividly dreaming. So now you might wonder, what's the relationship between REM sleep and memory? Since 19th century, there has been a lot of evidence suggesting that the sleep is the optimal period to consolidate the memory so that the memory can be converted to long-lasting form. But how does sleep actually strengthen the memory? What is the underlying mechanism? In order to answer this question, we really need to look into the brain. And there is a brain region called hippocampus, which is the essential region for the memory. So neuroscientists started to record the neural activity in the hippocampus during sleep so that they can check what's going on during sleep. However, a lot of studies focused on the non-REM sleep stage, so we don't actually know what's going on during the REM sleep. And that's why our team decided to unravel this question by checking the neural activity during REM sleep and see what could be the neural mechanism to consolidate the memory during the REM sleep. How do we actually check the neural activity in the hippocampus? So, we used very advanced technique, which I brought it here today. I don't know if you can actually see because it's really small and tiny. But with this miniaturized microscope, we can visualize the individual neural activity in the hippocampus of the mouse. And it is very light, so we can attach this on the mouse brain, and we can record the neural activity when they are freely running or in the following REM sleep session. And as you can see in this video, the neurons are genetically modified so that they can emit the fluorescent molecule whenever they are active. And we can capture this molecule with this microscope. So as you can see, it's very highly active when the mouse is running on the track. And the big advantage of this technique is that we can record not just few cells, but hundreds to thousands of cells. And let me show you another video of neural activity when the mouse is in REM sleep. As you can see, the hippocampus is not completely silent, and there are still some activities going on. So we can check if this neural activity pattern can be associated with the awake running experience. I know you want to know what we found during the REM sleep, but before that, let me ask how you strengthen your memory. Let's say you have a test tomorrow, or you have grocery list you need to remember, but you can't take notes with you, then how would you remember? Well, I guess you keep repeating the contents over and over so that you can strengthen those memory and you can recall those later, right? We found very similar mechanism during the REM sleep. When we deciphered the neural activity during the REM sleep, we found that the mouse is replaying the awake track running experience. So they just keep repeating what they've done during this awake training session over and over throughout the REM episodes. So we suggest this replay of the awake experience can be the key mechanism to consolidate the memory during the REM sleep. Then we got another interesting question. When we think about experience, it's not always the same. Someday you might expose to very novel experience. So in my case, I still vividly remember the first Canadian winter when I came to Canada. It was so freezing cold, and every freezing sensation was new to me. But this novel experience eventually got familiar after 6 years of PhD degree. So our team wondered how this different context of the experience changed the neural activity during the REM sleep. In order to answer this question, we put the mouse on the novel track for the first time. So this experience is extremely novel to the mouse. And then we record the following REM sleep session. And for the familiar experience, we put the mouse on the track every day. And once the mouse gets familiar to the task, we get the following REM sleep session again. Do you think we found any difference after novel or familiar experience? Yes, indeed. When we check the neural activity during the REM sleep, in both cases, the mouse was replaying the awake track running experience. However, there was a significant difference in terms of the quality of replay. So after the novel track running, when they were repeating this memory during the REM sleep, we found that the quality of replay significantly increased. However, once the mouse gets familiar to the task, this quality drops. So these results quite make sense when you think about novel experience. Everything is new to you. So you might need this high quality of replay during the REM sleep so that you can update those new information in your brain. I hope all this evidence convince you why we need to sleep. Sleep is the beautiful time when we build our own world full of new memories. So please don't hesitate to go to bed tonight, and I wish you all a wonderful night tonight. Thank you very much.